Welcome to AI Frontiers, where we explore the cutting edge of artificial intelligence research. Today we're diving into the language revolution happening right in your pocket. Picture this: you're having a heated debate with your smartphone about quantum physics at 2 a.m., and it's not just responding with pre-programmed answers, it's actually reasoning through complex concepts, remembering what you discussed 3 conversations ago, and building upon previous insights like a human colleague would. Sound like science fiction? Well, based on groundbreaking research from December 16, 2025, this future might be closer than you think. On this single remarkable day, 19 computational linguistics papers emerged from the arXiv preprint server, each pushing the boundaries of how machines understand, process, and generate human language. These weren't just incremental improvements, they represented fundamental breakthroughs that could reshape everything from how we chat with AI assistants to how computers help us solve humanity's greatest challenges. Today's presentation takes you on a journey through computational linguistics breakthroughs that are decoding tomorrow's language AI. We'll explore the fascinating intersection of computer science and linguistics, where researchers are developing memory architectures that mirror human cognition. These efficiency innovations are democratizing advanced AI capabilities, making powerful language models accessible to researchers worldwide regardless of their computational resources. We'll examine cross-lingual understanding technologies that enable global communication across linguistic barriers, and chart the path toward truly intelligent language systems. What makes December 16, 2025, particularly significant is how these papers collectively address the most pressing challenges facing language AI today. From memory and reasoning to efficiency and multilingual understanding. Computational linguistics represents something truly remarkable in the history of human knowledge. For the first time, we're not just studying language, we're teaching machines to understand, generate, and reason with it in ways that increasingly mirror human cognition. This field encompasses the challenge of teaching machines to understand the messy, ambiguous, context-dependent nature of human communication while working within the precise, logical world of computer algorithms. It's like teaching a mathematical equation to appreciate poetry, challenging, but incredibly rewarding when successful. Computational linguistics powers the voice assistants, translation apps, and chatbots we interact with daily, while simultaneously revealing profound insights into human cognition and communication processes. Beyond technology, this research is preserving endangered languages and breaking down cultural barriers, democratizing access to information across linguistic boundaries. Our first major research theme centers on memory and context management. Essentially, how can we build AI systems that remember and reason across extended interactions like humans do? Zhang and colleagues introduce the revolutionary CogMem architecture, drawing inspiration from cognitive science to create layered memory systems that mirror human cognition. Instead of simply appending conversation histories, which becomes computationally prohibitive and often confusing, this approach implements 3 sophisticated layers. Long-term memory serves as a repository for cross-session learning strategies and general knowledge. Direct access memory maintains session-specific information while handling retrieval of relevant long-term memories. The focus of attention mechanism dynamically constructs relevant context at each conversation turn. This architecture successfully solves persistent problems including reasoning bias, task drift, hallucination, overconfidence, and memory decay that have plagued conversational AI systems. The second major theme focuses on efficiency and resource optimization, making powerful language models accessible to researchers and organizations without massive computational budgets. Zhang and colleagues present ladder-side tuning, achieving 50% memory reduction while matching the performance of more resource-intensive methods. This breakthrough enables fine-tuning of 7 billion parameter models on consumer GPUs with 12 gigabytes of memory and 2,000 token contexts, conditions under which traditional methods exhaust available memory. The approach adds lightweight side networks that learn task-specific adaptations while keeping the main model frozen, fundamentally changing how we think about model adaptation. This isn't just about saving money, it's about democratizing access to advanced AI capabilities and making them available to researchers worldwide, regardless of their institutional resources. The implications for accelerating innovation across the entire field are profound. The third research theme addresses attention mechanism innovation, specifically tackling the quadratic scaling of self-attention with sequence length that has become a fundamental bottleneck as applications demand longer context understanding. Liu and colleagues introduce UniSparse, featuring multi-granularity compression and composite tokens that aggregate contextual information at different levels. This unified framework works across different modalities and can be applied as an acceleration plugin for existing models without requiring extensive retraining. The multi-granularity compression creates composite tokens at different scales, from local word-level interactions to global document-level patterns, maintaining both local detail and global context while reducing computational complexity. Experimental results demonstrate that Unisparse achieves 99% of full attention accuracy while providing 2.61 times faster computation than current state-of-the-art methods, addressing one of the fundamental bottlenecks in scaling language models to longer contexts. Cross-lingual and multilingual processing forms our fourth theme, emphasizing the development of language technologies that work across the full diversity of human languages. This research is particularly important for preserving linguistic diversity and ensuring that AI benefits speakers of all languages, not just those with abundant digital resources. The Bengali dialect translation work demonstrates how modern techniques can be adapted to work with low-resource languages while capturing subtle cultural differences in communication patterns. Perhaps most surprisingly, this research shows that well-designed retrieval strategies can enable smaller models to outperform much larger ones in specialized tasks. An 8 billion parameter model with carefully constructed retrieval augmented generation pipeline outperforms a 120 billion parameter model, fundamentally challenging our understanding of the relationship between model size and performance. This suggests that architectural innovations and intelligent data utilization can be more impactful than simply scaling parameters. The research reveals 4 transformative key findings that change everything we thought we knew about language AI capabilities. First, cognitively inspired memory architectures can fundamentally improve the sustained reasoning capabilities of large language models, addressing recurring failure modes that plague extended interactions. Second, significant efficiency gains are possible without sacrificing model performance. The ladder side tuning approach achieves 50% memory reduction while matching the performance of more resource-intensive methods. Third, sparse attention mechanisms can achieve near-perfect accuracy compared to full attention while providing substantial computational speedups, maintaining 99% accuracy with major performance improvements. Fourth, smart retrieval strategies enable smaller models to outperform much larger ones in specialized tasks, challenging assumptions about the relationship between model size and capability. Finally, diffusion-based language models can match or exceed the performance of traditional autoregressive models while enabling parallel generation, opening entirely new possibilities for language model deployment. The papers reveal 5 key methodological innovations that are becoming standard in computational linguistics research. Hierarchical memory management implements memory systems that mirror cognitive processes by structuring memory into multiple layers serving different temporal and functional roles. Parameter-efficient side networks focus on adding lightweight networks to existing models rather than modifying core architectures, allowing modular adaptation to different tasks without retraining entire models. Multi-granularity compression techniques compress attention mechanisms across multiple levels of granularity simultaneously, creating composite tokens that aggregate information at different scales. Structured retrieval augmented generation enhances language models through carefully structured retrieval systems rather than simply retrieving similar text passages. Finally, attention pattern preservation maintains pre-trained attention patterns while adapting models for new architectures or tasks, leveraging existing model knowledge while enabling architectural innovations. Each methodology offers distinct strengths while presenting unique implementation challenges. Zhang and colleagues present CogMem, a revolutionary approach to addressing one of the most persistent challenges in large language model deployment, maintaining coherent reasoning across extended, multi-turn interactions. The research tackles fundamental limitations identified in comprehensive evaluations like TurnBench, which revealed recurring failure modes including reasoning bias, task drift, hallucination, overconfidence, and memory decay. Current approaches typically involve appending full conversational histories, creating unbounded context growth, higher computational costs, and degraded reasoning efficiency as models struggle to identify relevant information within increasingly long contexts. The CogMem architecture addresses these limitations through a cognitively inspired, 3-layer memory system that serves as a repository for cross-session reasoning strategies, maintains session-level context, and dynamically reconstructs concise, task-relevant context at each turn. Experimental validation on Turnbench demonstrates significant improvements across all identified failure modes, with a layered design successfully mitigating reasoning failures and maintaining consistency across extended reasoning chains. Jung and colleagues address the prohibitive memory requirements for fine-tuning large models through ladder-side tuning, a parameter-efficient approach that revolutionizes accessibility to advanced AI development. As language models have grown to billions of parameters, the computational resources required for fine-tuning have placed these capabilities beyond the reach of many researchers and organizations. The research revisits ladder-side tuning, which adds a lightweight side network that learns task-specific adaptations while keeping the main model frozen. This architectural choice has profound implications for memory usage during training, as memory consumption is dominated not by parameter storage, but by computational graph maintenance required for backpropagation through the full model. Experimental validation spans multiple domains and model scales, demonstrating that LST matches CLORA's performance while using 50% less memory. The research demonstrates successful fine-tuning of 7 billion parameter models on a single 12 GB consumer GPU with 2,000 token contexts, democratizing access to large model fine-tuning for researchers with limited resources. Liu and colleagues tackle the quadratic scaling of self-attention mechanisms with sequence length through Unisparse, introducing composite tokens that serve as compact representations aggregating multigranularity contextual information. This represents a significant departure from traditional sparse attention methods that typically focus on pruning attention weights. The Unisparse approach creates a unified framework that works across different modalities and can be applied as an acceleration plugin for existing models without requiring extensive retraining. The multigranularity compression creates composite tokens at different scales, from local word-level interactions to global document-level patterns, maintaining both local detail and global context while reducing computational complexity. Experimental results demonstrate that Unisparse achieves near-perfect accuracy compared to full attention while providing substantial computational speedups. The method maintains 99% of full attention accuracy while achieving 2.61 times faster computation than current state-of-the-art methods, addressing one of the fundamental bottlenecks in scaling language models to longer contexts and enabling practical deployment of long-context models in real-world applications. The research landscape revealed in these papers points toward several exciting future directions that will shape the next generation of language AI systems. The success of cognitively inspired architectures suggests we're moving toward AI systems that more closely mirror human cognitive processes, not just in their outputs but in their internal reasoning mechanisms. Future language models may develop genuine expertise over time, accumulating knowledge and refining reasoning strategies through extended interactions with users and environments, leading to AI assistants that truly grow and improve through experience. The efficiency breakthroughs suggest a future where powerful language capabilities become increasingly democratized, with sophisticated language AI running on consumer devices, enabling privacy-preserving applications and reducing dependence on cloud-based services. Real-time, long-context language understanding could become commonplace, enabling new applications in interactive storytelling, real-time code analysis, and extended document understanding. However, significant challenges remain regarding reliability, interpretability, and ensuring AI systems with persistent memory remain aligned with human values and intentions. This comprehensive analysis was created through AI synthesis using advanced language models including GPT and Anthropic Claude Sonnet 4, ensuring thorough coverage of complex computational linguistics research. The text-to-speech synthesis is powered by Amazon services, providing clear and natural audio delivery of technical content. Image generation capabilities are enhanced through Grok technology, creating visual representations that support the research discussion. Human expert review has been conducted to verify accuracy and ensure proper interpretation of the technical findings presented in these papers. While every effort has been made to accurately represent the research, potential oversights are acknowledged, and original paper references are provided for readers seeking deeper technical details. This multimodal approach combines the efficiency of AI processing with human expertise to deliver accessible yet comprehensive coverage of cutting-edge research developments. Thank you for joining us on AI Frontiers as we explored these groundbreaking developments in computational linguistics. The 19 papers from December 16, 2025, represent more than technical achievements, they represent steps toward a future where the boundary between human and artificial intelligence becomes increasingly blurred through AI systems that can serve as genuine intellectual partners. These breakthroughs invite us to reconsider fundamental questions about intelligence, communication, and understanding, while opening new possibilities for human-computer interaction that we're only beginning to imagine. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.